Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I want to discuss about the surface integral. This is the topic in the Module 5, Vector Integration. So, in this video, we are going to know about what is the surface integral and what is the formula to evaluate the surface integral, what type of problems will be there, and we can see some of the examples here. First, see here, surface integrals. In mathematics, surface integral is used to add a bunch of values associated with the points on the surface. The computation of surface integral is similar to the computation of the surface area using the double integral except the function inside the integrals. Surface integral in calculus, the integral of a function of several variables calculated over a surface. More generally, an integral calculated over a plane of curved surface results in a surface integral representing a volume. See the definition here. An integral which is to be evaluated over a surface. An integral which is to be evaluated over a surface is called surface integral. The surface integral is given by double integral. You can see here double integral over S f bar dot n bar ds, where f bar is fni. Here f bar is f1 into I plus f2 into j plus f3 into k. So here what is the n bar? N bar is outward unit normal vector. What is the n bar? N bar is outward unit normal vector, and ds is projection of surface onto the planes. ds is projection of surface onto the planes. This is the definition of the surface. Here we can observe the figure here. So F is a continuous vector field. So F is the vector field defined on oriented surface S with unit normal vector N. So here we are taking F is a continuous vector field defined on an oriented surface S with unit normal vector N. Then the surface integral of F over S is, we can observe here. So this is double integral over S f dot ds. So here double integral over S f bar dot n ds. We can see here n bar is capital N. So this is often called the flux of F across S. So this is the surface integral over the vector field, and this is the formula for the surface integral. So we are going to use this formula to evaluate the surface integral on the plane. So see here how we can evaluate the surface integral. Let S be a surface with equation z equal to g of x comma y and r its projection on xy plane. If g, gx and gy are continuous on R and f is continuous on S. So f is continuous on S. Then the surface integral of f over S. Then the surface integral of f over S is double integral over S f of x comma y comma z into ds equal to, we can see this formula. So we can observe the figure here. This is the S, that is we are taking as z equal to g of x comma y, and this is the region. So we are going to evaluate this surface over this integral. So here we are taking continuous function. That continuous function is f of r and the surface is S, and here we have N. What is that N? N is a unit normal, outward unit normal to the surface at any point. N is a unit normal, outward unit normal to the surface at any point. So now, integral over S, F bar dot N bar ds is the normal surface or normal surface integral of f of r over s, of f of r over s. The projection of the surface on xy plane is, the projection of the surface on xy plane is ds equal to dx dy, dx dy by n dot k, dx dy by n dot k. Here dx dy, here z, in here we can remember like this the formula: x equal to I, y equal to j, and z equal to k here. So x equal to I, y equal to z, and z equal to k, if you are remembering like this. If you are having here dx dy, that means x, y is there, remaining z. So we can do dot product with the n, outward normal. So that of n dot k. If you are considering xy plane, we have to use this formula. And the projection of the surface on yz plane. If you are considering the projection on yz plane, then we can use this one for the ds. ds equal to dy dz by n dot I. dy dz by n dot I. So here dy dz, yz plane we are taking here. So here this one remaining, what is the x? X equal to I. So dy dz by n dot I. So this is the formula when you are considering the projection surface on yz plane. The projection of the surface on xz plane. The projection of the surface on xz plane is ds equal to dz dx. Here we are considering the xz plane. So remaining what left? Y. So n dot j. In place of I, we are taking here n dot j. So we can remember these formulas like this. So if you are taking xy plane, that we will get here dx dy. So remaining z left. So n dot k. In the same way, if you are considering that projection on yz plane. So here we can take dy dz. What is remaining left here? X. So n dot I. Next, coming to if you are considering that projection surface on xz plane or zx plane. So now ds equal to dz dx by n dot j. So here dot j is here. So here y left. So we are doing here n dot j. And to calculate the surface integral, already just now we observed the formula. Here. What is that formula? Integral over s, f bar dot n ds. So f already we can get from the problem, that is continuous function. And n, what is the n? N is the unit normal to the surface. N formula is n equal to del pi by det of del pi. So del pi by det of del pi, and that means they will give the pi plane also. So by using that pi plane, we can calculate the n value. After that, we have to do the f dot n. Here in place of d, in place of ds, which plane we are doing. So that means if you are using projection of the surface on xy plane, we have to use this formula. If you are taking projection surface on yz plane, you will take this formula. And if you are taking projection of the surface on zx plane, you will take this formula. So these are the important formulas, and we are going to use these 4 formulas to evaluate the surface integral. So we can get the better clarity about the calculation or evaluation of the surface integral. Now you can see this problem. So see the problem. The value of double integral over s, f bar dot n bar ds. So here what we have to know, the value of double integral over s, f bar dot n ds, where f bar equal to zi plus xa minus 3y square k. So what is the given vector? Given f bar equal to zi plus xj minus 3y square k. 3y square k. This is the f bar. Now, what they are asking, and S is surface of cylinder. S is surface of cylinder. So, x square plus y square equal to 16. X square plus y square equal to 16. So, this is included in the first octant. So, what they are telling, this is surface of cylinder. So, they given here x square plus y square equal to 16, and this is included in the first octant. So, first octant means you have to remember that is the first quadrant, we can say. First quadrant, the first quadrant, all positive values. In first quadrant, all positive values. That means you can take here first octant means all positive values. All positive values. All positive values. Between, so what they are giving here, z equal to 0 and z equal to 5. So based on this data, we are going to calculate the value of double integral over s f bar dot n bar ds. So first now I am writing the given data given f bar. F bar is zi plus xj minus 3y square k, and we are taking the cylinder, that is nothing but we can take it as pi. So pi is x square plus y square equal to 16, and the given z values also z equal to 0, comma z equal to 5. This is the given data. So here to evaluate this integral, so what we have to know? We have to prove that we have to calculate. What we have to calculate here? Double integral over s f bar dot n ds. F bar dot n ds. So here what is the f bar dot n ds value we are going to calculate? So for this we are going to know, already f is given in the problem. So we are going to know about the n value. We are going to know about the n value. So now here, how to calculate the n? Already given the formulas to you. So in the before slide, we can go through the formulas. Please by heart the formulas, then it will be very easy to calculate the integrals. So okay, is it clear? So I hope you got that idea how to remember the formulas also. So now n equal to, unit number equal to del pi by det of del pi. Del pi by det of del pi here. So now del pi by det of del pi. So what is the del pi value? So this is also basic formula we learned in the differentiation, vector differentiation. So this is dou by dou x. Del is I dou by dou x plus j dou by dou y plus k dou by dou z of pi. Del pi means this one. So we can write this one as I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. This is the del pi. So we can calculate the det value. Det value means already we know that square root of quotient of x whole square plus quotient of y whole square plus quotient of z whole square. So now you can see this. So now this pi equal to x square plus y square minus 16. So what is the n value? N value is del pi by det of del pi. So first we are calculating here del pi. Del pi is I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. Now I am going to calculate this one I. So I should know about the first dou pi by dou x. What is the dou pi by dou x? Dou by dou x of, with respect to x I am doing, pi is x square plus y square minus 16. So here when you are doing with respect to x, the value is here, respect to x, this is 2x plus 0 minus 0. Finally this value is 2x. So dou pi by dou x is 2x. Now with respect to y, so here dou pi by dou y of x square plus y square minus 16. So here dou by dou y of x square plus y square minus 16. So with respect to x, this is 0, plus with respect to y square is 2y minus 0. So 2y, this value is 2y into j, plus k into, here now we are going to calculate 2 dou pi by dou z, dou pi by dou z. So here dou by dou z of x square plus y square minus 16. Now I am doing with respect to z. So x square is constant, y square is constant, and this is also constant. Finally, this term is 0. Now I got 2xi plus 2yj. This is the value of del pi. This is the value of del pi. Now I am going to calculate n. N equal to, what is the del pi value? 2x into I plus 2y into j by square root x coefficient. So x coefficient is 2x whole square plus y coefficient is 2y whole square. So finally this value is, when you are taking the common 2 here, so xi plus yj, plus yj by here 4, I am taking 2 out. So if you are taking 4 here, 2 square means 4, 4x square plus 4y square. 4x square minus 4y square. Now I am taking root 4 is nothing but 2. So 2 into xi plus yj by 2 square root x square plus y square. So 2 will be cancelled. Finally I got n is equal to, what is the n value? So first I am writing del pi value. Del pi value is xi plus yj by square root x square plus y square. X square plus y square. So this is the value of del pi. Now I am going to calculate n value. So n equal to del pi. Del pi value is xi plus yj. Here xi plus yj, and n value, this is n. So del pi equal to xi 2xi plus 2yj. Now n equal to, we can observe here del pi by det of del pi. What is the del pi value? 2xi plus 2yj. So nothing but here square root of, just now I explained this one, I am going to explain again here. So 4x square plus 4y square. I am taking 4 out. So finally this is 2, taking 2 common, xi plus yj by 2 root x square plus y square, x square plus y square. So what is the n value? N value is xi plus yj by square root x square plus y square, x square plus y square. This is the n. Now what I need now? F bar dot n bar. So now F bar dot n bar. So F bar is zi plus xj minus 3y square k. 3y square k dot n. What is the n value? Xi plus yj by square root x square plus y square, x square plus y square. Now I dot I is 1. So z into x by square root x square plus y square. Next plus minus 3y square into, here j dot value is not there and k is not there. So that means this is 0. So finally here what I can get? So this is the k term I don't have. Next j term x into y by square root x square plus y square. So this term is 0. Finally I got here zx plus xy. Zx plus xy by this one zx plus xy by square root x square plus y square. This is the value I got here. What I got here? F bar dot n bar equal to xz plus xy plus xy by square root x square plus y square. X square plus y square. So that is equal to here zx plus xy by, already we are having the pi, that is they given x square plus y square minus 16. That means here x square plus y square equal to 16. So x square plus y square value is 16. If I take here root 16, finally I got f bar dot n bar equal to zx plus xy by 4. This is the value finally. So now I have f bar dot n. That value is xz plus xy by 4. Xz plus xy by 4. Now I am going to integrate the value. That means here I am going to calculate double integral over s f bar dot n ds. So now double integral over s f bar dot n means zx plus xy by 4 a4. So this is the value ds. So up to this part we got the final value. So here for the ds, which plane we are going to use? We are having three planes, xy, yz and zx. If you are having the projection on xy plane, we have to use this formula. If we are having the projection on yz plane, we are going to use this formula. If we are having the projection on zx, we are going to use this formula. But in the problem already, they given z equal to 0 and z equal to 5. Z equal to 0 and z equal to 5. So, if I know the y constant, z constant, if I have y variable, then I can use the formula for the yz plane. So that's why I am considering here yz plane. So ds I am taking here. ds is dy dz by det of n dot I. So for the yz plane, dy dz by dot I. So for that, I need the y limits and z limits. Already z limits we know, z limits are z equal to 0 to z equal to 5. Okay, so for that, we can observe here. So now here, I am taking yz plane. So I am consider yz plane. On yz plane, what is the x value? 0. On yz plane, x value is 0. Then, in the plane pi equal to x square plus y square minus 16, I can take the y limits here, put x equal to 0. So, y square equal to 16. Then, what is the y value? Y value is plus or minus 4. Y value is plus or minus 4. So, now, y limits are, in the problem they mentioned it is the first octane. That means all values are positive. So now I can take the limits from the 0. So y equal to 0 to y equal to 4. And already in the problem they given z equal to 0 to z equal to 5. So I know the limits of y and z now. I can integrate this value. Now, so y limits are y equal to 0 to y equal to 4 and z equal to 0 to z equal to 5. So now according to the formula I can observe here integral over s f bar dot n ds is I am taking here ds. What is the ds I am taking here? ds equal to dy dz by det of n dot I. So already I know the n value. What is the n value? We can observe here. N value is xi plus yj by square root x square plus y square. So that means this value is xi plus yj by 4. This is the n value. Now I am doing n dot I. So that means xi plus yj by 4 dot I. So I dot I is 1. So finally this is x by 4. I dot I is 1. So this value is x equal to x, n dot I is x by 4. So this value is x by 4. Now I am going to use this double integral over s f bar dot n ds is. So f bar dot L value. Here we can observe x, take the common, z plus y by 4. This is 4. into, here ds value is, what I got here, ds value dy dz, dy dz, and n dot I value. What is the n dot I value? X by 4. X by 4. So finally this is equal to double integral over s x into z plus y by 4 dot dy dz. Here I am writing this one. What is that? X by 4 as it 4 by x. So x will be cancelled. 4 will be cancelled. Finally, what I got here? So double integral over s. For here dy dz means I can write the y and z limits. So f bar dot n value is here z plus y into dy dz. Now what are the y limits and z limits here? Z limits are 0 to 5 and y limits are 0 to 4. I am replacing here. Now z plus y into dy dz. Now we can follow the integration formulas to integrate the integral. So now I am doing this is integral 0 to 5. Now this one I am doing with respect to y first values. So z is the constant. Integral dy is y. Limits are 0 to 4. Plus here integral y is y square by 2. Limits are 0 to 4. And dz. So now integral 0 to 5. So z into 4 minus 0 plus 1 by 2 into here 4 square minus 0 into dz. Now this is integral 0 to 5 4z. Here 4 square by 2 is nothing but plus 8 into dz. This value. So now I am doing with respect to z now. So 4 is the constant. Integral z is z square by 2 plus 8 into dz is z. Limits are 0 to 5. Now this is 2 2s are 4. So 2 into z square is 5 square plus 8 into 5 minus 0 is 5. So 5 square is 25. So 25 into 2 plus 40. So nothing but 50 plus 40. What is 50 plus 40? Total value is 90. So finally double integral over s. F bar dot n ds value is 90. So this is the way to calculate or to evaluate the surface integral. So you should know about the basic formulas about the integration and formulas for the planes yz and xz or xy plane, and what is the given problem we have to analyze. So I think we got the clarity about this problem. So I am moving to one more problem to get the better clarity about this type of problems. See this problem. If f is 2y into I plus minus 3j plus x square k and s is the surface of the parabolic cylinder, y square equal to 8x. What is given by here? Y square equal to x in the first octant. In the first octant means all values are positive, bounded by the planes y equal to 4 and z equal to 6. And what we have to show? So here we have to show that integral over s f bar dot n ds value is 132. So we should get the final answer is 132. So first of all, what is the given data in the solution? I am writing given data is given f bar is 2y into I minus 3j plus x square k. This is the given vector and s is the surface for the cylinder. What is that cylinder? Pi equal to y square minus 8x. So here they are telling that first octant. This is in the first octant means all values are positive. So they given y value is 4 here and z value is 6. That means y values are starting from 0. So 0 to 4 and z value also 0. So 0 to 4 and 0 to 6 we are having yz values. That means we can take here dy and dz, nothing but yz plane. So first of all, to evaluate this integral, you should know about the n value. What is the n? N is nothing but unit normal. First of all, what we have to evaluate? We have to show that. Is it clear? So what we have to show here? Integral over s f dot n ds is equal to 132. That means we have to calculate or we have to evaluate this integral. That should be 132. This we have to show. So for this we should know about the n, and already we know the formula for the ds. We can calculate by using this data, and already f bar also given. So we have to calculate the n now. What is the formula for the n? N is equal to del pi by det of del pi. Del pi by det of del pi. So n equal to, what is the del pi? First of all, what is the pi? After then we can calculate del pi. So pi is equal to y square minus 8x. They given the parabolic cylinder. Y square minus 8x. Now I am going to calculate del pi value. So I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Now we are going to calculate this one. This is I into dou by dou x of y square minus 8x. So with respect to x we are doing. So 0 minus 8 plus j into dou pi by dou, with respect to y we are doing y square is 2y, and plus k into dou pi by dou z. Here we don't have the z. That means this value is 0. So finally we got minus 8i plus 2yj. What we got? Minus 8i plus 2yj. This is about the del pi. So to calculate n, del pi by det of del pi. Del pi by det of del pi. What is the del pi value? Minus 8i plus 2yj. This is the del pi value. So what is the det of del pi value? Square root minus 8 is 16. 8 square is 16 plus 4y square. 4y square. Here I can take 4 as out. So here I take the common 2. So this is minus 4i plus yj. By here I am taking 2 common here. 2 square root. This one is 4 plus y square. So 2 will be cancelled. Finally I got 4i minus 4i plus yj by square root y plus y square plus 4y square plus 4. Now here, now consider already we are having the limits here. Y equal to 0 to 4 and y equal to z equal to 0 to 6. So now already I know that y limits are 0 to 4 because it is in the first octane. Z limits are 0 to 6. 0 to 6. These are having. So these are in the first octane. So that's why we are considering from the starting value, that is 0. So ds equal to dy dz by n dot I. Dy dz by n dot I. So what is dy dz? Dy dz we are going to calculate now. By dy dz into n dot I. Already I know the n value. What is the n value? Just now I calculated. That is minus 4 by square root y square plus 4. So based on that we are writing here. So minus 11y by dy square plus 16, and here n dot I value square root y square plus 16 by 4. These two are cancelled. Finally I got minus 11 by y. So this is the value of ds. ds equal to, we got here minus, this is f bar dot n ds. Okay. So f bar dot n ds, this is the f bar value, this is the ds value. So now this f bar dot n bar value is f bar dot n bar value is minus 11 by y, minus 11 by 4 into y. So now I am replacing here. Required surface integral is integral 0 to y limits are 0 to 4 and z limits are 0 to 6. F dot n value is minus 11y by 4 and dy dz. Now minus 11 by 4 is the constant taking out. Minus 11 by 4 integral 0 to 4 and 0 to 6 y dy dz. So integral y is y square by 2. Here minus 11 by 4. Integral y is y square by 2. Limits are 0 to 4. Limits are 0 to 4. And here, and integral dz is z. Integral dz is z. Limits are 0 to 6. Now we are replacing here minus 11 by 8. So here 4 square minus 0. To here 6 minus 0. 6 minus 0. So minus 11 by 8 and 4 4s are 16 into 6. When you are simplifying that, we are getting here minus 132. So here, what is the absolute value for the total area when you are finding? If you are getting minus also, you will take it as plus only. According to the direction, you will get that negative or positive values. So here, what is that absolute value? Absolute value is 132. Absolute value is 132. So here we got double integral over s f dot n ds value. I got 132. I got 132. So this is only they are asking to show here. Double integral over s f dot n ds is 132. So we proved the value. So we got the 132. So this is the way we can calculate the given surface integral by using the formulas of projection of planes, and we can analyze the problem properly. Then we can get the solution very easily. So I hope you got the clarity how to solve the surface integral. What is the surface integral? And these are the references I used here to know about what is the surface integral, what are the formulas we are used to calculate or evaluate the surface integral, and some of the examples. I used these references. I used the textbook Engineering Mathematics written by IKV Iyengar and Mathematical Engineering Mathematics textbook written by B.S. Grave, and some of the Google links I used here. So if you want, you can refer these textbooks and links to get the better clarity about the remaining problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.